Hi everybody. We're talking about trig functions of acute angles. If you look at page 46 in your book, you're going to want to write down the title and the date, and then you also want to copy down on page 46 the following trig ratios. So what we're looking at are sine, cosine, and tangent, and then of course their reciprocal identities. And now what we're doing is we're looking at these ratios when they are not in the coordinate plane. So they're not necessarily sitting in an x and a y axis. When you have that scenario, what you can analyze are the opposite, hypotenuse, and the adjacent sides of a right triangle. So go ahead and pause the video, and you're going to want to copy down these trig function values of your acute triangles. So these are available on page 46 as well. Okay, example 1. Go ahead and pause the video after I explain it here. You're going to copy down the directions and copy down both of these right triangles. For each one of these right triangles, by the directions, it says find the sine of A, the cosine of A, and the tangent of A. A is just the given angle, and in this case, here's angle A, so I'm going to circle it. You'll also notice that I added in these little marks. These are right triangles, so you can go ahead and mark the 90-degree angles. Okay, so this is angle A right here, and we're looking for the sine of A, the cosine of A, and the tangent of A by the directions. There is a couple of different ways you can remember these different trig ratios. You could just simply memorize them. But there is a memory device that we can use. It looks like this, SOHCAHTOA. So go ahead and pause and write this down. Just make sure you spell each one correctly because these letters represent these trig ratios that we just wrote on the last page. Okay, so let's look at sine. Sine is O over H. And as we wrote in this chart here, O stands for the side opposite of the angle, and H stands for the hypotenuse. So we're going to figure out what side is opposite, which side is hypotenuse, and then we also need the adjacent. The hypotenuse is always the longest side. So in this triangle, our hypotenuse is here. Adjacent and opposite are going to depend on the angle that you're working with. So since this is angle A right here, if you put your pencil point in angle A and you lay your pencil flat over, the side that it's going over, or the one that's over away from it, is the opposite side. That means this side over here must be adjacent, and adjacent means it's right next to that angle. Although both of these sides are adjacent, this one is already labeled hypotenuse. It's a special type of adjacent side. So then the other side over here must be your adjacent. Okay, look at sine. Opposite over hypotenuse. Opposite over hypotenuse. The cosine is the adjacent over the hypotenuse. So 28 over 53. Reduce if possible. These two examples here, they don't reduce, so you just leave the fraction in lowest form. Tangent is opposite over adjacent. So opposite over adjacent. And again, reduce when possible. Same thing for 1b. So again, we're looking for the sine, cosine, and tangent of angle A, and that's by the directions. So I'm going to identify angle A. That's the one I'm looking for, sine, cosine, and tangent of angle A. I'm going to mark it, and I have to label the sides. So the hypotenuse is always the longest side. It's always the one opposite the right angle. So here's my hypotenuse. The other two sides are going to depend on the angle you're working with. So since I'm working with this angle A, the side over here would be the opposite. The one that's over away from it is the opposite. The one that's next to it then is adjacent. And I always label in that order. Okay, go ahead and set these up and you can use this ratio if needed. So pause the video and try to set each one up. Opposite over hypotenuse. Hopefully you put K over Z. And your other two are listed below. How did you do? If you made any mistakes, go ahead and fix them, and we'll move on to the next example. So the next thing that we're going to be looking at are special angles of some special right triangles. This is on page 50 in your book, and you can take a look at it there, or you can copy down the same chart right here into your notes. So this is the same chart that you'll see on page 50 in the book, but definitely take a few lines and pause the video and copy this down in your notes. So we're going to use this chart, this table of special right triangle values, 30, 60, 90, and 45, 45, 90, to find the value of each trig function that is listed below. So copy down example 2, and you want to copy down 2a and 2b. And go ahead and pause the video so that you can do that now. Eventually, we're going to learn how to find each one of these values by drawing a picture and finding these trig ratios. But today, the book wants you to just familiarize yourself with them by identifying them on the chart. So let's look up the sine at 60 degrees. So you're going to find the sine column. You're going to find 60 degrees, see where those two pieces of information meet, and you will see that that just equals the square root of 3 over 2. Do the same thing for tangent of 30. So see if you can find it. Hopefully you said that the tangent of 30 is square root of 3 over 3. So for this problem set today, you are literally just going to be looking up these values on the table. In this next problem, we're going to be finding the side lengths of a right triangle, and we're going to be finding the 6 trig functions. Go ahead and pause the video and write down this entire question. I'm going to circle some important information and underline and put some boxes around things. Suppose ABC is a right triangle. You have side lengths of A, B, and C. So these are your side lengths. And a right angle at angle C. Now it tells you to see figure 3 in the book, and I'm going to actually draw that figure as well. Find the unknown side lengths using the Pythagorean theorem. Okay, so this is important. Find the unknown side length using the Pythagorean theorem. So we're going to find the side, and then find the values of the 6 trig functions for angle B. Okay, now this is different. In the examples that we did at the beginning, we were looking for angle A. So if I flip back here, these were both looking for angle A. In this new example, we are looking for the trig values of angle B. So just keep that in mind. Rationalize denominators when applicable. Okay, so I'm going to go ahead and draw out what figure 3 looks like in the book. So this is the way that the book draws it, and what they do is they label all of the angles with capital letters and all of the sides are lowercase. And you can label A and B however you want. Look, the directions say to make C the right angle, so that's what I did here. A and B you can do whatever you want with. However, I'm going to stick with what the book is doing. Notice I'm putting this at the point, not in between there. And this is angle A and this is angle B. Okay, next I need to label the sides. The sides are always opposite the angles. So if this is angle A, then that means the side opposite will be side A, little a. If this is angle B, then little b, side B is opposite, and then C would go here. Notice these are lowercase letters. The next thing you need to do is label them with their given information. A equals 6 was given, and C equals 7 was given. The directions say use the Pythagorean theorem to find the unknown side length. So I've got the Pythagorean written down. Remember the theorem that we used earlier in the year used X and Y and R, but now we're just using A, B, and C again because we're not in the coordinate plane. Okay, I'm going to go ahead and plug in what I know. And I'm going to go ahead and multiply. So 6 times 6, 7 times 7, I'm going to solve the equation for B. When you are doing the Pythagorean theorem, don't forget the last step is to take the square root. Now, technically, when you take a square root and you're working with an equation, you get both positive and negative. Don't write this down, but I just want to show you. If you get a positive square root of 13 or a negative square root of 13, you have to consider that this is a length of a side. So a side will never have a negative length. It has to have some sort of a positive measure to be considered a length of something. So even though you have an equation, you're taking the square root, you don't have to worry about the negative answer. It will always just end up being positive whatever. So in this case, it's positive square root of 13. The other thing that you have to find in this question is the 6 trig function values for angle B. So now that I have the sides, I can go ahead and start setting up those trig functions. This time angle B is my focus. So I'm going to go ahead and circle that, and I'm going to label the hypotenuse. It's always your longest side. It's always opposite the right angle. And then I need to find out which side is opposite and which one is the hypotenuse. Okay, so here's angle B. The side that's away from it, over here, would be opposite. And so that means the other side would be adjacent. Remember, I'm finding the 6 trig function values, so I'm going to start writing them out below. And I'm just going to start with the main 3, the sine, the cosine, and the tangent. It doesn't hurt to have SOHCAHTOA on your paper in front of you, and you can also be looking at those ratios that we wrote here at the beginning. That's perfectly fine as well. Okay, so I'm going to start with the sine of angle B, and the sine, remember, is the opposite over the hypotenuse. So opposite over hypotenuse. Square root of 13 over 7. The cosine. The cosine of angle B is the adjacent over the hypotenuse. 6 over 7. And the tangent is the opposite over the adjacent. So if we're looking at angle B, that would be the square root of 13 over 6. Remember, your other 3 trig functions are just going to be the reciprocals. If you can't remember what matches with what, always go back to your original guide here, and you can see that sine and cosecant go together, and cosine and secant, and so on. So you can always refer back to that if you get lost on those. Okay, so what I'm going to do is I'm going to write these as their reciprocals. So go ahead and pause the video and just flip them over, and we'll rationalize in a moment. So here's what I have so far. I literally just took the reciprocal of each. Now what I need to do is rationalize any radicals that are left in the denominator. So I'm going to multiply by the square root of 13 and times the square root of 13. This middle answer is just fine. You don't have to rationalize that. Go ahead and try to rationalize this last answer. And you have them all rationalized, and they're all in the simplest form. Let's try one more of this type, and again, we want to recreate figure 3 out of the book, which is that right triangle, label the sides, and then we can find the missing side and do the 6 trig functions. So I labeled my right triangle, now I'm going to label the sides. So remember, the sides are opposite of the angles. Sides are always lowercase, and let's see what's given. Fill that in. So you can see that we are missing A. So go ahead and write down the Pythagorean theorem and plug in your given values to find side A. Don't forget that you're squaring these numbers, not multiplying by 2. So be careful when you're doing that part. And don't forget you are taking the square root at the end. These aren't all going to be radical or square root answers. As a matter of fact, some of them work out as whole numbers. And if that's the case, just go ahead and write that number down. Okay, now the next thing you're going to do is write the 6 trig functions. And again, the directions say of angle B. So go ahead and write out your sine, cosine, and tangent. So before I can actually fill these in, don't forget you need to label your sides. Find your hypotenuse. This is angle B, so in relation to angle B, figure out which side would be opposite. And label your adjacent. Okay, go ahead and set up your ratio. So pause it now and see if you can set up your first 3, and then we'll do the reciprocals. So the first 2 are just fine, but remember you've got to rationalize any denominators that are radicals. So I have to rationalize this one. Okay, go ahead and pause the video and see if you can write out your 3 reciprocal identities. So the first one is just the reciprocal like that. The second one, once you did the reciprocal, you had to rationalize. Now this third one may seem like kind of confusing. What should you do? So this would be kind of a mess if you tried to do the reciprocal of this. So what I always recommend is go back to that original ratio that you set up. So instead of 2 over the square root of 21, you can write square root of 21 over 2. And then you'll notice that that doesn't even need to be rationalized. So the last part of the assignment is going to talk about an important idea of cofunctions, page 47. And again, you definitely want to copy these into your notes. So go ahead and pause the video and copy these down now. The next thing that you want to do is write example 4, the directions, and then go ahead and copy down 4a and 4b. So we're going to write each function in terms of its cofunction. You're looking for the word sine with an angle that's all by itself. So if you look up above here, you'll notice that there is a sine in 2 different places. There's a sine right here, and there's a sine right there. But we're looking for the one that has just the sine by itself with an angle. So not 90 minus an angle, just the sine with an angle. So that would be this first sine right here. Okay, now what I can do is I can take that and I can replace it with what it equals. So this is what I have right here. I'm going to equal it to its co-function. So now what I'm going to do is I'm going to plug in any given information. So this is A, and A is just the angle. So what I can do is I can take out that A and I can replace it with 9. The one thing that's important to know about cofunctions is that these 2 cofunctions are complementary. So they add up to 90 degrees. So that's where this formula comes from. Okay, so all you have left to do is take 90 minus 9. And so the cofunction of the sine of 9 is the cosine of 81. And if you were to add 9 plus 81, it equals 90. So it works. Go ahead and identify the cotangent. What does that equal? And write down that cofunction and see if you can plug it in. Okay, so here's what I have so far. And I'm going to plug in tangent of 90 degrees minus 76. If you do the subtraction, you end up with 14 degrees. Okay, one last example. Let's try a cosecant. So cosecant of 45 degrees. Go ahead and write what it equals and see if you can find its cofunction. Did you get secant of 45? If you did, then you've got it right. These are the assignment problems that go with this lesson. Have a great day.